Have you ever wondered why potato slices turn brown once you cut them? Or why a yellow banana gets dark spots over time? Both of these phenomena have the same cause: enzymatic browning triggered by an enzyme called polyphenol oxidase or PPO. In this activity, I will find out how this enzyme works by turning a banana from yellow to brown in just a matter of seconds. Then I will explore how I can keep my potato slices looking fresh. Let's go! In this experiment, the materials that we need are banana, water, pot, and timer. The first thing that I am going to do is to fill our pot with tap water. Then I'm just going to bring it into the stove and let it boil. This is the banana that I'm going to use in this experiment. As you can see, it is color yellow and has a little bit of brown spots. First is peel the 1/3 portion of the banana. Then carefully dip the bottom third of the peeled banana into the boiling water. After 30 seconds, add the remaining 3/4 of the banana. Observe it for another 3 minutes. What happens to the peeled banana when you submerge it in hot water? Initially, nothing changed, but then its appearance gradually and slowly transformed from yellow to brown. Remove the peeled banana after 30 seconds. After 30 seconds, the banana changed its appearance. It had lost much of its freshness. It became soggy and mushy rather than being fresh, possibly because the fruit tissue is damaged by the heat. Remove the unpeeled banana into the boiling water after 3 minutes. And when the banana has cooled down, peel the banana. Look at the fruit that was inside the peel. Did you expect the banana to look like that? Yes, I expected that the fruit inside would just appear as an ordinary banana when it is peeled, simply because there was a peel protecting and covering the freshness of the banana. The peel prevents the enzymatic browning inside the banana. Enzymatic browning in potatoes. The materials that we need are lemon, potatoes, saucer, spoon and fork, water, distilled vinegar, milk, knife, chopping board and timer. Cut 2 slices from the potato on a cutting board. How do they look? When I cut the potato, they look normal, ordinary, and fresh. However, the wall of fruit cells, which are responsible for protecting the texture of fleshy fruit, were damaged. Pierce one of the 2 potato slices with a fork several times. Then observe both slices for 15 to 20 minutes. How do the potato slices change over time? Do you notice a difference between the 2 slices? If yes, can you explain why? There was enzymatic browning happened on both slices of potato, but the one that was pierced several times with a fork changed color immediately. It had gone darker. When the potato cut, certain enzymes are exposed to air. As a result, when I pierced the potato several times, it caused even further damage to the cells. exposed to air, and released more enzyme, which resulted in the other slice becoming darker than the other slice. Cut 5 more slices from the potato and place each slice on its side. Immediately after cutting, sprinkle milk on top of the first slice, distilled vinegar on the second slice, lemon juice on the third slice, and water on the fourth slice. Keep the last slice as is. Then pierce each potato slice several times with a fork. What do you think these liquids will do to the potato? During enzymatic browning, polyphenols reacts with oxygen. If something else reacts with the oxygen, enzymatic browning won't occur. So I think these liquids will help to prevent or stop enzymatic browning to occur. Observe all 5 potato slices for another 15 to 20 minutes. How are the potato slices different after 15 to 20 minutes? What did each liquid do to the potato slice? Can you explain? As we all know, milk is a good source of protein. The milk proteins helps to reduce enzymatic browning. That's why the first slice where milk was used stayed fresh despite of being cut, being pierced several times, and being exposed to air. The second and third slice, which are the acidic solutions such as lemon juice and distilled vinegar was used, it doesn't turn to brown. In fact, the one with vinegar looked whiter than the other. The one that I sprinkled lemon stayed fresh too, simply because lemon juice contains citric acid, which is a natural antioxidant. Adding citric, ascorbic, or other acids lowers the pH. As we know, acidic liquids slows down the enzymatic browning. PPO doesn't work well in acidic environments. Therefore, when you apply lemon juice and distilled vinegar to potato slices, it helps to prevent the potato from turning brown and prevents the enzymatic browning or oxidation process. In the slice where the water used stayed fresh too. My grandmother always put the vegetables into the water after she cut them because it prevents them from browning. Because the water reduces contact with oxygen and prevents enzymatic browning. It inactivates or destroys the PPO enzyme, so enzymatic browning will not occur quickly. In the last slice, which is the 5th slice, there was a browning all over the potato since I didn't sprinkle it with liquid like I do with other slices. I pressed it several times with a fork without any mixed liquid, so it damaged more cells and triggered the enzymatic browning. As a result of adding this liquid to the potato slices, it slows down the enzymatic browning and keep the potato slices looking fresh. The activity that I did is connected to our topic, which is enzymes, because cells contain thousands of enzymes. These enzymes do all of the work necessary for the cell to live its life. Once you cut, slice, or bite a fruit, it damages its cell wall, allowing to expose some of its cells. According to an article, the actual mechanism that causes browning in apples, potatoes, and other fruits and vegetables involves an enzyme called polyphenol oxidase, also known as tyrosinase. PPO and polyphenols are found inside a fruit cells. Normally, the PPO and polyphenols in a potato never touch each other. That's why freshly cut potato aren't brown, just like in my experiment. But when I cut or slice it, it causes cell damage. Fruits and vegetables turn brown when the enzyme polyphenol oxidase reacts with oxygen in the air. The enzyme of fruit are being released, making the fruit turns brown quickly. Cutting or slicing a potato also exposes cells to air, which contains oxygen. This triggers the oxidation reaction that causes enzymatic browning. Environmental conditions affects enzymes activity because when the fruit tissue damage because of heat, cold, age, or mechanical stress, the walls of fruit cell damage and brings PPO and polyphenols together. As a result, fruits or vegetables turn brown or enzymatic browning occurs.